Today I'm going to go through 5 examples of how to write a polynomial if you're given its roots. And just for clarification, if roots doesn't make sense to you, these are the solutions of the polynomial. These are the places where the polynomial function will cross the x-axis. In order to write a polynomial, we're going to have to first take our roots or our solutions and make them back into factors. If you remember, when you're given a factor, you set it equal to 0 and you solve it. And the sign of the number that's in the factor will change. Well, in order to put a solution back into a factor, we have to undo that process. So we're going to write x minus in front of every one of these numbers. Now that we've done that, we're going to multiply these binomials together. You can only multiply 2 at a time. It doesn't matter which 2 you choose. It's completely up to you. When I multiply these 2 parentheses together, I'm going to do a double distribution. I'll take the x term and I'll multiply it times both terms in this final parentheses. That gives me x squared minus 2x. Now I'll go back, take the negative 1 and do the same thing. Negative 1x plus 2. I'm going to combine the like terms so that I can simplify that parentheses. Now that I've done that, I will multiply my binomial times my trinomial. Again, I'm going to use a double distribution. I'll take the x term, multiply it times all 3 terms. That gives me x cubed, negative 3x squared, and positive 2x. Now I'll go back, take the negative 3, and do the same thing. The final step is to combine your like terms, and we're also going to go ahead and write it in function form. Since I only have one x cubed, I'll write that down. I often will cross out the terms that I've used so that I know that I've used all of them correctly. Now I'm going to combine my x squared terms. Now the x terms. And finally the constant. In number 2, we're given 2 roots, but I want you to realize that anytime you see a radical, radicals travel in pairs. So if you have a positive square root of 2, you're also going to have a negative square root of 2. So you have to finish out the solutions. That means we have 3 roots, and so we're going to have 3 factors. If I put x minus in front of a negative 1, that double negative will become a positive. Then I'm going to have x minus the square root of 2. And in this final one, again, I have a double negative. X minus a negative 2 will be a positive square root of 2. Now the good thing is on these 2 parentheses, you have conjugates. And if you remember, we do not have to do all 4 steps of FOIL on a conjugate. We only have to multiply the first terms and the last terms because we know the middle 2 answers are going to cancel each other out. So I'll go ahead and do that. When I multiply the first 2 terms, x times x, I get x squared. And when I multiply the last 2 terms, negative square root of 2 times positive square root of 2, I get negative square root of 4, which is negative 2. Now, since I have a binomial times a binomial, I'm going to do FOIL, or double distribution. I'll take the x, multiply it times both terms in the second parentheses. That gives me x cubed minus 2x. Now, I'll take the 1, multiply it times both terms. X squared and negative 2. Since my terms are out of order, In this final step, I'll write down my function notation and I'll rearrange my terms. Number 3 is very similar to number 2. Initially, we are only given 2 solutions, 2 roots, but in the same way that radicals travel in pairs, I does also, because if you remember, I is equivalent to the square root of -1. So if I have positive 3i, I need to also write down negative 3i. So I have 3 solutions, 3 roots, which is going to result in 3 factors. X minus 5, x minus 3i, and x minus a negative 3i, which will become x plus 3i. Once again, my second and third parentheses are conjugates of each other, which means I only need to multiply the first terms and the last terms. When I do that, x times x gives me x squared. When I multiply negative 3i times positive 3i, I get negative 9i squared. Now don't forget, I squared is equal to -1. So we're going to make that replacement and substitute I squared and replace it with -1. -9 times -1 is positive 9. Now I'll multiply these 2 parentheses together. Again, this is FOIL, or double distribution. I'll take the x, multiply it times both terms. That gives me x cubed and 9x. Now I'll go back, take the -5, multiply it times both terms. -5x squared and -45. Final step, let's write it as a function. F of x is equal to x cubed minus 5x squared plus 9x minus 45. Number 4 is similar to 2 and 3, except the given I is part of a complex number. So complex numbers also travel in pairs. If I have 3 minus I will have its conjugate, 3 plus I. I'm going to have 3 factors to write. You're probably going to want to use brackets on some of these. My first factor is x minus 4. The second factor is x minus this whole entire complex number, 3 minus I. The third factor is x minus 3 plus I. Now there's several ways you can go about solving this, but I think it might be easiest to just go ahead and get rid of the parentheses. So I'm going to distribute the negative to both terms inside the parentheses on both of these factors. So now I have x minus 4, x minus 3 plus I, and x minus 3 minus I. In these second 2 parentheses, I have a trinomial times a trinomial. Now we learned before, you've got a couple options on how you can solve this. I'm okay with you using boxes, or you can do a triple distribution. Write out your terms and then combine the things that are alike. I'm going to distribute. I'll take x and I'm going to multiply it times all 3 terms in the second parentheses. That gives me x squared minus 3x minus ix. Now I'm going to take -3. Do the same thing. That will give me -3x, positive 9, and positive 3i. Finally, I'll take the I and do the final distribution. That gives me ix negative 3i, and negative I squared. Now there are a lot of things to combine, and there's also some things that'll cancel out. I'm going to look for the things that cancel first. I notice that I have a positive ix and I have a negative ix. So let's go ahead and cross those out. I've also got a positive 3i and a negative 3i. Those are going to cancel. Don't forget, I squared is equal to negative 1. So if I have a negative 1, I actually have a plus 1 here at the end of this problem. I think I've canceled everything I can, and I've done the substitution. So let's go ahead and combine the like terms. I don't have anything to combine with the x squared, so I'll write that down. I can put the negative 3x and negative 3x together, and that gives me negative 6x. This 9 will combine with this positive 1, and that gives me 10. So now it's time to finish this out. We'll do a double distribution. First, I'll take x and multiply it times all three terms. That gives me x cubed, negative 6x squared, and positive 10x. Now, I'll go back, I'll take the negative 4 and distribute it to all three terms. That gives me negative 4x squared, positive 24x, and negative 40. In my final step, I'll combine all my like terms. X cubed doesn't have anything to combine with, so I'll write it down. I can combine the negative 6x squared and negative 4x squared to get negative 10x squared. 10x and 24x combine and give me 34x. And finally, negative 40 doesn't combine with anything, so we'll write it down. All right, final example. Once again, we have a complex number. Complex numbers travel in pairs, and so we're going to write down its conjugate. Remember, the conjugate has the same exact numbers with the opposite sign in the middle. So I'll write 1 minus square root of 5. I will have 3 roots, which is going to result in 3 factors. Again, when you write these complex numbers as factors, you might want to use brackets. I'm going to have x minus the first complex number, 1 plus the square root of 5. And then I'll have x minus the second complex number, 1 minus the square root of 5. I'm going to clean up these two factors by distributing my negative to both terms. Now I'll write everything with parentheses. The first factor will become x minus 1 minus square root of 5. The second factor, x minus 1 plus square root of 5. I'm going to take care of the second and third parentheses by doing a triple distribution. When I take the x and distribute to all three terms, I get x squared minus 1x plus square root of 5x. Then I'll take the negative 1 and do the same thing. Negative 1x, positive 1, and negative square root of 5. Finally, I'll take the negative square root of 5 and distribute it to all three terms. That gives me negative square root of 5x, positive square root of 5, and negative square root of 25. Now let's clean this up. Let's start by canceling out things that are opposites. I can see here that I have a positive square root of 5x and a negative square root of 5x. So I'll cancel these out. I also have a negative square root of 5 and a positive square root of 5. So these will cancel. The square root of 25 is actually 5. So this term becomes negative 5. Now let's look for things that can combine. I can't put anything with the x squared term, so I'll write that down. I can combine the negative 1x and the negative 1x, and that gives me negative 2x. This positive 1 and this negative 5 can combine, which gives me negative 4. Now I'll finish out with a double distribution. I'll take the x and multiply it times all three terms. That gives me x cubed minus 2x squared minus 4x. Now I'll take the negative 1 and do the same thing. Negative x squared, positive 2x, and positive 4. My final answer is f of x equals, the x cubed doesn't combine with anything, so I'll write that down. Negative 2x squared and negative 1x squared is negative 3x squared. Negative 4x and positive 2x is negative 2x. And the 4 doesn't combine with anything, so that'll finish out this problem.